Welcome to Seen and Solved. I'm Tim Pennington, your host. And today we'll be chatting with Connor Callais, a product manager at Hubbard-Hall. And we're going to be talking about the keys to successful immersion applications. Stick with us. We'll be right back.
You're listening to the Seen and Solved podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
So, Connor, welcome back. Give us an update on what you've been, I know you're a product specialist now, product manager. Tell us all that does, what the product line is, so people get an idea of what your expertise is all about.
Sure. So I primarily work with our conversion coating applications, whether that be functional conversion coatings with zinc or manganese phosphate, or conversion coatings that do more so metal coloring. So black oxide over steel and stainless steel, or copper and brass. Work primarily with those product lines because they kind of synergize in terms of the way that they're used and the way they're applied, and kind of meld together into the different applications that our customers work with.
Do you have a sense of like what percentage of shops are actually doing these types of conversion coating? Because there's, it seems like those are specialties that people are kind of working with a lot.
So there's a wide variety of different customers actually use these sort of products. So, if you think about the automotive industry, there's a whole suite of applicators that primarily or solely focused on serving the automotive markets. That's primarily with zinc or manganese phosphate coatings, whether it be for components that are going to be exposed externally, being an automobile out on the road and needing to withstand years of just the corrosive environments, or different fasteners that have to kind of hold the vehicles together. There's a lot of captive operations with firearms and a lot of parts that go into, the tooling market. All those sorts of things usually go through a conversion coating. And then a lot of people will apply these coatings more for a decorative or aesthetic purpose as well. So that could be a captive operation or a job shop that focuses on doing those sort of coatings.
Before we begin, keys to successful, what are some of the more common mistakes that you see, just in general? Maybe list 2 or 3 that people make with their conversion coatings.
Top 3 would probably be, first would be, surface preparation. So making sure that surface is clean and ready. Are they using the right products to get the cleaning done correctly? Are they maintaining that cleaning bath, or does the part that they're working with need some sort of activation step or acid step prior to actually going into the conversion coating? That's a common mistake or issue that we see with a lot of different customers. Second probably would be, are they maintaining their line in the right conditions? A lot of times they may be using the right product, they're just not using it the right way or in an optimal way for them to be able to achieve the best results that they need for their product. And lastly would probably be within the post-treatment, not thinking enough about what sort of post-treatment they need to apply. Are they needing certain performance out of the part once it has the coating put on it? Do they need a certain look that they're going for, or are they set up in a way to apply the right corrosion protection for that sort of part in order to, have a successful operation?
You mentioned something. They've got the right product, but they're not using it correctly. How does that even happen? Is it just they drift away from it over time? The people that maybe that product when it was installed were there, and it just people are not paying attention to the proper way to use that product? How is that happening?
I mean, there's a number of different reasons people could be using the wrong product. Maybe it was the right product at the time when they originally started using it, and they just haven't changed after decades, perhaps. When their parts or their specs have changed, or they have worked with a chemical supplier that thought this would be the right product, but over time they've kind of changed either chemistries or chemical suppliers and just kind of deviated from what they have used always and what they probably should be using nowadays. A lot of times that comes with either the applicator going through an acquisition, or they have turnover after someone had been there for a long time. So just knowledge about the process that they're using.
Well, let's start right from the very beginning. I mean, racking seems to be right at the very top, which we're going to be, in these type of applications, immersions. getting it racked properly. Talk about that for a bit of how important that is.
There's a couple different ways with these immersion processes that parts can be processed. Obviously, probably the most common and cost efficient would be using a barrel process. So think of a long elongated barrel that has perforations on the outside that allows the solution to come in. And generally that's going to happen with the parts tumbling on the inside. This is really good for small parts or parts that don't really have super complicated geometry, or they aren't too heavy to where as they're tumbling, it's not going to cause damage to the actual parts. Tends to be one of the more cost efficient ways to process parts too, because you can load them up in a barrel, lock the door, send them down the line, unload them, be done. You don't have to rack individually every single part. But for parts that either are heavier, more delicate, or just have a lot more critical measurements, and you can't really work with or can't really risk having those dimensions change, parts are going to have to be racked. And that has its own benefits and challenges. One of the nice things about having a barrel process is you end up with parts that generally are going to have a uniform coloration all the way throughout. And you don't have to worry about the agitation as much because those parts are going to be tumbling while they're processing. Whereas with racking, sometimes the parts may need to go through almost like an agilift, where when they're in the solution, you need to either make sure that that solution itself, whether it be the cleaner or the actual conversion chemistry, is agitating so you don't end up with splotchy areas or, parts at the back of the tank come out better than the parts at the front. That's a consideration that has to be brought in as well. Rinsing tends to be a little bit easier when you have parts racked, just because you don't have a physical barrier of a container that's holding all the stuff, limiting the actual interchange of the solution. But those are kind of two different ways that people are generally going to have to process. And then probably not as common, but sometimes, especially with really, really, really small parts where you may not have a ton of them that you're having to do, sometimes people will use an immersion basket. Works kind of like a barrel, but parts are just kind of statically set in there. And usually those will be lined with a really fine mesh to make sure you're not losing any actual parts. And the biggest thing with those is just making sure that we're agitating that basket enough so that you don't end up with those nesting marks.
And then we get into surface prep, the cleaning. Talk about that for a bit. Okay, they got the parts racked properly, hopefully, and then we get into the surface prep part of it. Why is that so important, I guess, to go forward?
Well, with all these conversion reactions, whether it be metal coloring, where you're going to be changing the surface chemistry to change the actual color of it, or you're going to be building a crystal off of the surface, you need to have good solid contact with the solution and the part in order for that reaction to occur. So, if we have scale that's left over on the surface, that's going to inhibit that reaction. Or if you have, some oil or organic contamination that hasn't been properly removed prior to, you're going to see that on the resulting finish once that part's been processed. So making sure that we are fully prepping that surface prior to actually going into that reaction step, that's going to be key. And generally, we're going to be looking at the cleaner. On these immersion processes, 9 times out of 10, you're going to be using some sort of alkaline cleaner, just because it has the best detergency and you're able to kind of utilize the strength of some of those caustic components to really help facilitate that cleaning process. But actually picking the right cleaner itself can also have a large impact. So for lines that are, if you're going to be running a barrel process in particular, you really need to make sure you're using a cleaner that can emulsify all those oils that you're removing effectively. If you have really heavy contamination, there are certain cases where we can utilize an oil splitting cleaner, but that requires a little bit extra equipment and setup in order for it to work properly. Because otherwise, we are going to be running to a step where you take the parts out of the cleaner and they go straight through that oil layer and redeposits everything you just taken off right back onto the parts.
So, Connor, we've talked a lot about surface cleaning and prep on the organic side. Inorganic, just as important. Let's walk through that for a bit and tell us what are some very important details that shops should be paying very close attention to on the inorganic side.
Sure. So a lot of the parts that are going to undergo these sort of conversion coatings, they're going to have some sort of either a heat treat or they're going to be coming from a wire mill where the parts are actually drawn out. But either way, they're going to have a lot of either scale or inorganic residues, so stuff that a surfactant or a cleaner is not necessarily going to be able to remove on its own. And addressing that is just as critical as removing all the organic oils and greases that are present on the part. So we can do that a couple different ways. Sometimes they may be mild enough to where we can utilize a cleaner that has certain chelators or sequestering agents built in. Think of like either EDTA or glucoheptanate. Those are really good at kind of removing some of those mild scales from the surface of the part, which works great for customers that have limited number of tanks, because you don't necessarily want to have to add 2 to 3 tanks just to add in another acid step. But sometimes utilizing an acid is the what we have to do in order to properly address those issues. So when we have to use an acid on the line, there's a lot of different options that we can work with. We can work with really mild phosphoric acid based cleaners or acid additives that can be used as kind of, once you go through that cleaning process, then you go to an acid step where it kind of bites down on those inorganic contaminants, preps the surface and activates it prior to going into that conversion coating. Those tend to be more liquid products that you kind of would make up like a cleaner itself. There also are acid salts, which are great for, just having a relatively cost-effective solution that can be dosed in accordingly. The only trouble with those is you just have to make sure that you get the salts dissolved into the liquid properly. Or a lot of customers will just use a commodity muriatic acid on those lines if they need to pickle the parts appropriately before they go into the actual conversion coating.
At what point would you probably use an acid?
A lot of times parts maybe have been sitting in, with customers in the South where the parts are sitting in a somewhat temperature controlled area, but no matter what, they're still going to have some sort of, mild rust on the surface of the part. Or they've just come out of a heat treating plant and they just look awful because they're covered in a lot of the burned on scale and atmosphere from that heat treating process. And that stuff may be able to get removed with the cleaner, but sometimes it's just not. So they may have to go on and get addressed with an acid step prior to going into a metal coloring application. Kind of just depends on the application, job shops. They're generally going to use some sort of acid step, or at least have that option on their line. Whereas some sort of captive operations where they have a lot more control on the inbound material and they're not trying to address a ton of different inbound materials, they may not necessarily need to use an acid step.
I guess the problem in all this is a lot of these shops don't know what's on the parts, right? They don't have a real clear understanding. Their customers don't often just give them a list of here's what we use, here's the oils, here's the fluids, and that kind of starts a guessing game sometimes, doesn't it?
Yeah. And that's something that we're able to do. Your chemical supplier should be able to kind of work with you, understand what the scope is of the material that you're trying to process. Understand where there's certain failures in your quality. So whether, if you have a set or a series of, problematic or rejected parts, we can kind of look and evaluate to pinpoint what those issues are, whether it was from a surface prep side or something a little bit later on down the line.
I can see that happening very much so with that. But you talked about rinsing. I've not heard a lot of people talk about, really, is that a trouble spot sometimes if you're not rinsing it completely for the next step?
Absolutely. It's not too uncommon to walk into a plant or to an application and look at the rinse tanks and you're not even sure which ones are the rinse tanks because they're so dirty or static. Generally, we're going to recommend people keep those rinses flowing, at a reasonable rate. I usually like to have the rinse tank turnover, every 10 to 15 cycles. So, if you're going to have a 200-gallon rinse tank, you want to flow enough water through there to where after whatever time would pass for 10 loads to go through that rinse tank, that rinse has been, fully turned over in terms of the volume that's replaced. You can kind of reduce the amount of water you're using and still increase the effectiveness of the rinsing step if you use like counterflowing rinses, which we talked about before. But essentially, you have kind of 2 or 3 tanks that are tied up, and you're refilling the secondary one, which then backflows into that first rinse tank, which is going to take the brunt of the rinsing step in the first place. That tends to be a way to really increase the effectiveness of rinsing and cut down on the amount of water that you're being used. Another thing that's commonly used is some sort of agitation in the rinsing too. So you have more of that mechanical action, whether it be circulating the rinse with some sort of pump or adding like an air sparge underneath. That kind of adds a scrubbing action that helps, fully rinse off the previous application or the previous steps chemistry, along with all the contamination that's been brought up into it, and helps make sure that those parts get fully washed off before they go on to the next chemical step.
Even with the sparges, I mean, you're going to have the right nozzles, right? I mean, everything's got to be pretty much dialed in correctly for it to work. You just can't, it's not just off the shelf with some of this stuff, right? It's got to be.
Yeah. Like if you have a barrel line, a barrel process, like we were talking about with the cleaning side of it, you need to make sure that the immersion time is enough for all the contamination that's kind of loose around the parts, but kind of trapped within that barrel, has enough time to be expelled out of that barrel itself too. We've seen many times where, maybe the parts themselves were clean, but some of that residue was still left inside the barrel. And then when it goes from, ambient temperature rinse into a hot chemical application, it just kind of reapplies back onto the part and causes problems down the line as well.
Well, like I said, it's very interesting what all the things that we've talked about over the is that you've got to look at from the very beginning, the racking, the surface prep, even the rinsing, which I really had not really thought too much about that the controls, and then like I said, the post treatment. And again, I think a lot of shops, it would behoove them to really bring in someone like yourselves and someone from Hubbard-Hall to really go through that line and make sure that what they're doing is effective. And if not, replace it with something that's really going to be working for them, because I'm sure that you have found things that people were using just really weren't that effective for them.
Right. Yep.
Yeah, definitely. Well, Connor, I appreciate it. Thank you very much. I know we'll talk again and get some more information from you, but I very much appreciate this insight. Thanks.
Absolutely, Tim. Good talking to you.
Thanks for listening to Seen and Solved by Hubbard-Hall. For more episodes, visit hubbardhall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Awcast.